Welcome, everyone. Thank you for joining us for today's webinar. My name is Odette Hines, and I'll be your moderator today for the webinar entitled Next Generation Depth Sensing, co-produced by Christopher from Framos and Miro from Intel. Before we start today, I do want to provide you with some housekeeping rules. All participants are in listen-only mode. If you have questions during the webinar, please type them in your question section in your GoToWebinar control panel, and I'll ensure that they're answered at the end of the webinar. If we do not get your questions today, we will send the responses to you after the webinar. The on-demand version of the webinar will be available within 48 to 72 hours. We will ensure that that is sent to you as well. If you require a conversation or a demo with one of our members from our sales team, please ensure that that request is in the question section, and we'll ensure that a member of our sales team will reach out to you. Now, without further ado, I'll turn the time over to our co-presenters, Miro and Christopher.
Yeah, thank you very much for nice introduction. My name is Miro Mlejnek. I'm working for Intel Corporation for REALSENSE Group. I'm based in the UK, in Swindon. Swindon is our European headquarters. And I'm responsible for all technical and commercial relations of REALSENSE Group within Europe, Middle East, and Africa. In my track today, I will do my best to show Intel depth camera and tracking module roadmap. What are the products, where we are focused, what's our mindset, how we designing present and maybe future things. I do my best also to explain you the principle, how the system is operating, what's the devil in the box. And then I will hand over to Christopher, who will be talking about, specific solutions made up in our joint cooperation between Framos and Intel, if it goes for true industrial usage and bespoke industrial camera. So I need to start with the legal disclaimer, just to make our legal department happy. And we can go to our science of a computer vision. So 3D sensing at the moment is a big thing for Intel, and I believe also for other technology companies. We believe that we can very well serve in our technology in verticals like facial authentication, applied robotics, scanning, which may be any form of 3D, 2D models, distance scanning, close-up scanning, volumetric measurement, and also making especially surveillance cameras systems very smart, improving tracking systems, because you can also add to the RGB stream the information about the distance of a particular object of your interest. So these are literally the main verticals where you can see our cameras in action, used by many, many OEMs around the world. As I mentioned, I'm working for part of Intel called Intel REALSENSE Group, and our mission is literally to sensify computing and sensify computers to enable computing devices to see, understand, if they can understand the reality, they can also decide with the right algorithm what will be the way of interaction with the external world. And obviously, because you can store all the data you're processing, you can use them for improvement of algorithm over the time and learn from its environment. So literally this process of seeing, sensing, understanding, then deciding how to interact and learn out of it is literally the principle of machine learning and artificial intelligence. So we literally mimicking this process very precisely, and this is the main goal of our group, of our activities. For those joining our bridge also with some sense of commercial feelings, you can see that this market is really booming, and just related to the depth vision sensors is expected size of the market over $30 billion through 2023. So let's say 4 years from now, we will see much bigger presence of depth sensors revealing the distance of the objects. So reflecting maybe the first slide, these are the main verticals. You can see our products utilizing the depth and tracking. So drone solutions, surveillance systems, applied robotics, even in the form of the humanoids or industrial robots. We do tracking modules serving very well in human machine displays for augmented and virtual reality headsets. And also you can find our cameras in consumer electronic products like tablets, slates, ultrabooks, and standard PCs. So this slide is, we're starting to talk a little bit more the science. Why is a 3D important, and how you can benefit out of it. It's very easy to a little bit twist the system with the optical illusions if you're just processing the visible stream. So if you're operating just with the RGB, there may be scenarios when the computer vision system may be, a little bit confused and will not be capable to tell you what I'm looking at. If example will happen, the scenario when I have 6 dummies printed with the white nose information. So for RGB sensor or even for human eye, you're not capable to tell me how many things is standing in a row on a stairs. You're probably just judging that this is a shape of a human body, yeah, because your brain is processing, oh, this is a shape like the human head, and you can see the shoulders, but you can't tell me how many is, standing in a queue. Depth camera will definitely reveal it very easily. So this is a beautiful example showing, what is a good RGB channel, what you're probably using today without any problem, and you know how to utilize the color stream. But the depth is revealing another level of information, helping you to provide the right level of segmentation, yeah, understand the distances. And if you're building some smart device like robot, if he's understanding the distance of the objects, he can precisely make proper decision what to do. Yeah. So if you think about the cameras and what are the typical usage scenarios, so you can detect the edges on the objects. You can use it for sizing and volumetric measurements and calculations. This is very typical scenario. If using the depth cameras in a robot or drones, as they can understand the distance of the objects, yeah, they can avoid the collision. And if I will start to retrain my, for example, object recognition engine, and I will add the depth to this information, I will significantly increase and improve my object recognition ratio. So my my ratio understanding the object will be much, much higher. So these are main things, where we see the importance of a depth vision in combination with the RGB, helping you to reveal more information for your advanced system. So maybe summarizing all the slides, the typical usage models for the combining RGB and depth camera is in robotics. Yeah, it's helping in the recognition analytics because adding depth is eliminating these spoofing principles, like you can twist the system just showing the picture of someone, but the depth camera is properly revealing the structure of a human face or bodily parts and all these bits. Other section is related to drones, and this is again related to collision avoidance. Face identification, it's maybe like sister to recognition analytics of a individual and a human. Depth camera is perfect for 3D scanning. Yeah. Virtual reality, this is an agenda with many facets, so virtual reality, you can use the 3D camera for scanning the objects and creating the 3D models for modeling in a 3D, and you can enrich plenty of games and digital content with such information. Other approach is that virtual reality is also supported by our tracking modules, when we can create actually inside out tracking system based on our tracking module. So it is avoiding all these necessities to have a light towers and cameras looking the human body, what is your posture, because tracking module can substitute all these very complex technologies into one. It drives the cost down, and the solution is delivering almost minimal latency. Yeah. And obviously, as I mentioned, dimensioning and box measurement as a last case is also a very nice role-playing scenario usage for 3D imaging processes. So summarizing all these bits, what I said, these are real examples, real pictures from our customers making the volume solutions. So like Levi's store in America, where you can check and fit the clothes before you will buy with the virtual system, because it's scanning your volumetric size of your body, and it's precisely know, yes, this size, I don't know, 10 or 8 is exactly fitting to your body. 3D face identification for access control. This is very booming business in hospitality services, in traffic and transportation. Warehouse inventory management, we can combine again the depth vision with the tracking modules. Similar is applying to robotic and drones, measurement dimensioning, and on, as you can see on the pictures. So just keep your imagination running wild, and I believe that many of you joining our call today may be coming back to us, to Intel and to Framos with interesting ideas, and we do our best to help you know to design interesting and nice product. Then again, back to the science, how the stuff is running, and just to give you flavor how we're doing the products. So we mimicking literally the functions of a human head. We decided for certain technologies on a computer vision based on observations, what is happening in the nature. And if you're looking at all living species on the planet, you will never see any living species with one eye. Yeah, so we have 2 eyes, we have a pair of eyes, some insects have more eyes, and this is proven by nature that probably stereoscopic vision is the most robust technology in terms of also as a cost and performance and usability because it's proven by nature. Yeah, so RealSense technology camera, do not expect the camera is smart. This is just the sensor to tell you the depth of every pixel or the distance of a pixel from the camera. But as you can see, the processing of a vision is happening inside of the camera. It's not causing any payload to the system, and this is we implemented very similar algorithm as a human brain is using to process the vision from the left and right eye. Yeah. I mentioned we do also tracking modules. So tracking module is mimicking the functions of inner ear mechanism in a human head and the center zone of a cortex in the brain. And the rear cortex of a brain, this is the place of your brain where you're understanding the reality, you're understanding the objects, you understand what you see, you can understand all these dependencies and domino effects, what will happen if I will take an action. So we have also a specific chipset, you know, called Movidius. You can utilize it that he can see into the RGB stream or to depth stream and have a better power and performance to decide what will happen if I'm the robot or drone. Yeah, so this is exactly matching this sensing, understanding, interaction, and learning as principles of machine learning and artificial intelligence. Now, a few words about technologies we're providing. Intel is a company which I believe at the moment we are the only company providing all possible technologies invented for 3D sensing. I wouldn't like to claim that particular camera is the best camera on the planet. It depends on the scenario, usage model, light conditions, etc., etc. And that's why it's important to have a discussion with us and with Framos. What type of technology is the best for your scenario? Is it indoor? Is it outdoors? What are the light conditions? And etc., etc. So it's important, first of all, to select the right technology matching your expectations. At the moment, we're offering 2 technologies. This is structured coded light. What is based on a triangulation process. This is SR300 family, and we have also cameras based on a stereoscopic matching. At the moment, stereo is very likely probably positioning this technology like 70% of all usages on the world is basically running on a stereo matching, and this business is still booming and booming, and many companies are actually working from the structured or coded light to stereo. However, we still manufacturing coded light cameras because they are very good, especially for close-up metering, very precise, and they are very good, especially for facial identification engines and solutions. Stereo is very robust and is very good for usage outdoors. Is just final close to this slide, structured light, coded light is very precise. Yeah, but the downside of this technology is that it can be used outdoors, yeah, especially on a direct sunshine, and because it's using a highly coherent laser projector, the reach of a camera is typically like between 1 to 1.5 meters, because you need to keep in your mind that camera must be human eye safe, so there's a limited reach. Stereo camera is very robust, can operate, can glaze the light, can look into the sun. There's no problem. There's no any problem with interfering with other cameras. Downside of stereo technology is that camera must be calibrated. Yeah, so camera is sensitive to some strong mechanical, movements or thermal stressing, and camera accumulates certain error over the distance. Yeah? So you need to be careful what type of a depth camera you're using based on a stereo, based on your scenario, what is your first and last plane of interest over distances. Yeah? And for both technology, we're providing complementary technology related to the tracking. So we do tracking modules when you can inject the depth stream from the camera and RGB stream with the information about your position. So you can inject SLAM hardware accelerated solution and providing your system with the 6 degrees of freedom about your actual position of your system. And also you can memorize your trajectory, how you was moving, your product was moving over the time in a particular area. So our products are complementary and running together. So very briefly, stereo technology is same technology as human brain is processing vision from the left and right eye. You know that left and right eye can see the scene a little bit from the different perspective, and this is processed by your brain, that your brain is selecting similar bitmaps or significant pixels and is using them to perceive and understand the depth. Yeah, so this is the way how is it running. Typical question of a customer is when I can use the stereo camera, and answer is very simple. If you can see the center with your own eyes, our camera does the same. Yeah, so stereo is very robust, can meet almost every scenario, but the limitation again is you need to be careful with calibration. And the second one is over bigger distances, camera is less precise. For those willing to go into the deeper science, we're using algorithm called consensus over disparity shift. So ASIC inside of the camera is processing a whole depth vision. That means that our camera is completely hardware and software agnostic. So all processing is happening inside of the camera, and camera is only feeding the system with the depth information. Yeah, and the way how camera is doing it, so it's a little bit simplified. Obviously, ASIC is doing much more things behind, but if you're looking how this stuff is running, what's the devil in the box? If you know the baseline, the distance between left and right eye in millimeters, and you know the focus in the pixels of this camera system, which is, as you can see, 942 pixels. And you see what is the disparity in the pixels. So millimeters times pixels divided by pixels gives you the value in the millimeters. So this is how camera is revealing the distance of every pixel in the field of view as a value of a distance. So this is the process. How is it running? Yeah. Very briefly again how ASIC is running. So he's clipping the picture of a left and right eye. He's considering, okay, I will, for example, select this left eyebrow of David West, a basketball player, and this absolute distance from the zero axis is 80 pixels on the left eye and 120 pixels on the right eye. Then ASIC is running 120 minus 8 is 40 pixels. You know the baseline, you know your focus, and then output from the ASIC will be that the distance of this eyebrow is certain distance in the millimeters. And this is what this ASIC is doing, tile by tile, all the time very fast. And this is the way how is it running. So summarizing, how is it going? So ASIC is basically tiling the screen into small tiles and comparing if I see similar pictures, if I see the same, that is taking consensus, okay, this is my point of interest, and is running the calculation of a distance. Next question is that we have two types of a system. We're talking about a stereo, which is active and passive. So passive stereo camera is not using any laser projector, and active is using laser. And then some customers are somehow confused. So you say the stereo is running without a laser. Why you have a laser in it? So laser there is not used to illuminate the scene for more light. So you need a laser to address specific scenario. An example, your robot will be standing in front of the white plain wall. There will be no visible structure. So then in a stereoscopic matching vision, a robot can't distinguish any significant pixel to calculate the distance. The analogy is like you driving the car in a fog. So you don't know what's your speed, you don't know where you're going. So same is for robot. So in this moment, when you start to beam the random dots from the laser projector, ASIC thinks that something is printed on the wall, and it will use it for calculation of a distance. Yeah. So if you see on the picture here on a right bottom, I have a laser active on the right side, so there's a more light projected on the boxes, and you can see that the noise is much lower because these plastic boxes, they have no visible structure in certain areas. So the laser is helping you just to add more diversity, more pictures, and more pixels, and this is helping to reveal the depth. So passive and active stereo. So active stereo is just helping if you have a material which doesn't have any structure or some patterns which camera can use for calculation of a distance. So this is just to explain the technology, how is it running. On this slide number 17, because Framos will be sharing this information with you, you have side-by-side comparison of all camera technologies we're selling at the moment on the market and what are also the cornerstone for industrial versions you can get from Framos. Yeah, and you can see that we have a cameras with a rolling shutter, global shutter. They are optimized for certain distances. You see what is the field of a view. You can see what is a depth measurement error. Yeah, and some solutions are also coming with the integrated inertia motion microcontroller unit. So camera is capable to tell you its actual position in environment. So this is a slide comparing the products. Very briefly on the software. So our camera technology is open source project. So all software Intel is providing is free of charge, is open source. And if you're getting the open source software, it means that you can easily create even drivers for your own operating system. And we pre-compiling as a standardly supported all versions of Windows, so 7, 8, 10, any Linux, iOS X, and Android. Yeah, so these all are supported by default. But again, if you have some kind of like homebrew runtime, because we give you the source code for the kernel elements, you can create your own stuff. We're supporting almost all programming languages. Yeah, there's a plenty of community wrappers like robotic operating systems, LabVIEW, MATLAB, Unity from Microsoft, Unreal for those making the content for games and media. So this is very rich supported ecosystem. And in a moment, if you think like, okay, I'm not competent maybe to create, I don't know, gesture control software, skeletal tracking, again, you can come to Framos, and Framos can help you in the creation of a specific software, or you can go entirely to the ecosystem and buy specific solutions from companies listed on this software provider window. If anybody in the audience here on the call is calling in from the software company and you're willing to have a collaboration with Intel, I'm more than happy to talk to you, maybe enroll your company and your software for RealSense cameras and promote it as a Intel. So similar slide, just talking who is doing what. So an example, as we are on a Framos call, Framos are the top-notch premium experts in a skeletal tracking software. They are really delivering very high performing solution. So in example, you have a slide, just to find out who is doing what. Yeah. So again, Framos is a champion in skeletal tracking at the moment. So now briefly about the products. As you can see, we are nearly a decade on the market. Yeah, we shipped incredible number of cameras. And there are two types of solutions you can get from us, and same from Framos. So you can get something which is on the shelf. We call it camera. It comes in a box with a tripod, cable, manual. And this is something for proof of a concept and testing the technology. But in the moment you like to go for tight level integration, you have to go after modules. And this is the way how you can create something industrial or embedded. So you can buy the components and build own version of a camera. And again, you can ask Framos for help because they are very knowledgeable of all these, vision technologies, how to combine it together, Intel camera with somebody else camera, different imagers. If you're looking for different lenses, different housing, this is all where you can go for help to ask Framos. So on this slide, I'm just summarizing what it is. So on the right side, we have something we call cameras or peripherals. It comes in a nice aluminum body with a shielding glass. There's a tripod in the box, yeah, and these are the standard products. However, these are seen as a standard consumer electronic devices, so it's not targeted for usage outdoors and in industrial equipment. So that's why if you're looking for tight level integration, you can get from Intel distribution channel and from Framos, you can get these components like depth module, computing ASIC card, or structured light depth module. So these are the components you can embed into your system and maybe make them invisible to the external client. So you have these two options, and it's just your decision which is the best one for you. Again, for consulting, feel free to come to Framos. You know, Christopher's team is very skilled. We have more than 3 years, very close collaboration on a global market, and they will definitely tell you exactly what is the best solution to meet your expectations. So summarizing what I said, you have option for peripheral solution. You can get these components on this slide on the bottom section. So all these options are available and immediately available on the market. I would like to talk exactly about these slides because you can read out them later on. So this is a camera SR305 representing coded light technology, excellent for face identification or for close-up 3D scanning. Yeah, it's not a high resolution because for face identification you need to have a good ratio between the resolution and the precision. So VGA is probably, in our opinion, the best option. Yeah, camera is limited to 1.5 meter distance. So bear in your mind and strictly indoors. Then we have a battery of cameras based on a stereoscopic matching. So we have a cameras with the active stereo rolling shutter. Same if you bring the robot with the global shutter and active stereo as well. We have a same guy with integrated IMU. So this is a Bosch BMI 055 microcontroller as a gyro and accelerometer. And we have also tracking camera, but do not expect this is a camera. This is really tracking module, which is blending functions of optical odometry and integrated IMU inside, and based on a Kalman filtering principle and algorithm, we generating hardware SLAM function. So this is a highly performing solution for those building the robots or drones. I believe that you will like this technology, and again, feel free to talk with the top confidence with the Framos. They can help you how to integrate it and how to fly together with other cameras. So that's from my side as a presentation, and just very briefly in a few minutes, just to show you how camera is working with our software. You need to remember after my call that our camera is processing the vision and the depth information inside. So inside the camera is the ASIC who is processing the vision depth, and it's not causing any payload to the host. So it doesn't matter what's your host. Yeah, if this is Xeon processor or Intel Atom or ARM processor, you know, it doesn't matter. So all this processing is happening inside of the camera, and you can freely pick the platform of your choice. Technically saying, the platform must be capable to run with operating system, must have a USB connectivity, and that's basically it is. Yeah, so if you see, I have a connected camera called D415. It's a rolling shutter camera with a 55mm baseline. You have a full control what you like to do with the camera. So I can control the RGB camera, I can control the features of the depth. So an example, if I will decide I'd like to see a stream in infrared and in the depth, and I will kick the camera on. So you can see me presenting to you. On the left side, you have a picture what camera see in infrared. But don't get wrong, camera is not infrared. Camera is just coming when the lens is not fitted with the infrared filter. So you can obviously use camera in a total darkness just to see in infrared. So camera is coming with the lenses without the IR filtering. And on the right side, you can see the depth image. So you can precisely see my hand, you know, in a 3D. And again, this is not infrared picture. This picture is just the colorification when I'm assigning to the particular distance gradient of a color. So you can see that bluish tones are the closest, yeah. So light blue is like 1 meter of a distance, yellowish is 2 meters distance, and on and on and on. So if I will, for example, go for very close up of a depth, so let's go without RG infrared. So you can see me in the details in a 3D, and I can present you that I'm not cheating on anyone. So I can go to the vision in a 3D, and you can see if I'm sliding my picture, you can really see my face in a 3D. You can see details of my glasses. So this is a stereoscopic camera, and this is really performing in a highly illuminated room where maybe probably cameras based on a laser may suffer the troubles. And I can also, if I will kick to the camera RGB stream. So inside of the camera, you have technically saying two isolated cameras. One is for depth, and the second one is for RGB. So obviously, I can go for RGB as well. So now you can see me in a RGB in my Intel office. And because ASIC is the guy who is setting up the timing in a milliseconds, and he's used to synchronize all video streams together on a precision of a frame. So if I know this information, then I can assign on the same time stamping precision. If I go back to 3D, and I will go back to some, better resolution of myself, looking into the camera, then I can use this RGB channel as a texture to coat my face, and you can see me now in a 3D, immediately. And all this show what you see in the picture is happening in the camera. So the question is how much of a computing I do need for my system is basically on your side. We will not answer that. You need so much of computing, which is related to how much of performance you need to do for graphic processing. So obviously, I'm now running on a mid-class of a Intel-based notebook from HP, but the information about the distance and the depth is coming from the camera. It's not causing any payload. If I go back to 2D, and then I'm looking after how this depth stream is running. So when I'm sliding in my mouse in a field of view, you can see the distance of every pixel. So this is visible here in the corner, on the left bottom corner of my video stream. So you can see that, in example, my forehead is a 54 centimeters. If I'm leaning towards the camera, it's 45. So the wall behind me in this rec section is a 2 meters 2 centimeters. If I will point the camera to distant object, distant wall in a room, you can see more noise because laser can't reach this distance. But the wall is distant now 3 meters 48 centimeters. So this is how this camera is processing. So RGB channel gives you RGB ratio considering the pixel result. This camera tells you the distance of a pixel, not the color information. You can combine them together. Final bit I'd like to present to you in the last minute, because I need to hand over my stage to Christopher, is that you can control all the functions of a camera. So an example, now you see that my laser is active, and I'd like to show why this laser good for. So if I will be looking into the plain wall behind me, you can see that camera is revealing very precisely the distance of the wall. There's no any noise. So the distance of the wall is exactly 1 meter and 13 centimeters. But because if I'm looking in a RGB, so behind me is the plain wall, and on the wall there's no any visible pixel. Camera can just see the edge of this chair here, but nothing else. If I will switch the laser off, you see the effect immediately. Camera is generating lots of noise because camera can't spot any visible visual information, and this is ending in a noise. In example, my hand is perfectly visible in a distance because camera can see structure of my skin, wrinkles, hair, my watch. Everything is fine. But if I'm fading away from the field of view, it's gone. So that's why you have these lasers. So it's not to illuminate the scene, it's just adding the texture or the structure to the object. So this is just for your understanding, and I believe that this is just for introduction. This from my side to present you the depth camera. Now I'll disconnect my depth camera and I will go to tracking module, just to explain you that the tracking module is not the per se camera like you expect, but this is a device acting as a hardware SLAM. So I'm running exactly the same software. I didn't touch anything. Everything is isolated. Actually, all our cameras are isolated with a transportation layer from the hardware underneath. So you can easily swap between cameras and you can stay and fly with your software you created before. So there's no any need to touch anything. So now you can see this connected tracking module T265. If I will kick the guy to live, you see the result from him. So this is a camera system based and built on a two fisheye imagers as a sensors and a black and white. The field of view of of each image is 172 degrees, and system is also equipped with the accelerometer and gyro. So if I start to move in my system, I will grab it now. Starting to move, you can see that gyro and accelerometer are starting to read out the values. And you can also see that in a field of a view, this highly actually deformed picture with the spherical effects. This is how this system is observing the reality in the room. If I will drop the camera to the same position, we can see also that camera came exactly without any drift back to the starting position. And now just to show you what happened is that actually you can see the trajectory of my movement over the time. Yeah, so you can really see that this was my trajectory, and this is how system is memorizing his path of a movement. So when I'm moving with the camera in a time, yeah, you can see what is actually happening. So this is a beautiful example how to create navigation indoors for system. When you have no reach to the sky, you can use the GPS. So you can create literally like hardware / GPS to operate for navigation indoors in a building. And this is the platform called T265. So this is all from my side. If you have any questions, feel free to submit it. And I'm handing over to Christopher. Thanks for your attention.
Yeah, thank you very much, Miro, for the presentation. My name is Christopher SWIHW. I'm leading product management department at Framos. And I'm going to present to you now the Ethernet version of the RealSense cameras that we have built. Odette, can you make me the presenter?
You are now the presenter.
Thank you. Is my screen visible?
Yes, it is.
Thank you. So, as you have seen, Intel has a lot in the portfolio, and its modules, and it's the camera peripherals. And we have built an Ethernet version of the camera. And today I'm going to tell you, first of all, why we did it, and second, how it works and what it can do. And first, I'm going to very briefly talk a little bit about the vision market and the technology. You've heard already a lot, so I'm just going to amplify what Miro has just said. Then I'm going through the specification of the camera, some targeted applications, and then I'm going to reveal the software roadmap for those of you who have already bought the camera, and also the hardware roadmap. So what we see in the vision market, and this is what you have also seen in Miro's presentation, is that vision is taking off and 3D cameras are taking off. And what we see is that this growth is mainly driven by the consumer market. So consumer-based applications, they need those cameras. And what does that mean for the technology is, if there's consumer business, then there is large volume, and you see it in the orange bars here, and there are shorter development cycles in the technology. And this kicks off a spiral, and the spiral means that technology gets better and better with every innovation cycle, and it gets cheaper and cheaper with all the volume which kicks off the economies of scale. So this is what we see right now in the market, and this is also why 3D technology becomes better, really high quality, for affordable prices right now. And Miro has already touched 3D technologies and what is in the Intel portfolio. Basically, there are 4 basic technologies around 3D. It's time of flight, it's laser LiDAR, it's the structured light, and it's the stereo vision. As Miro has also told you, it's about technology fit to your application. Some of them are more expensive, some of them interfere with each other, so you don't have multiple camera setups. Structured light, very accurate, but you don't use it in direct sunlight, and you don't use it for far distance. So there are advantages and disadvantages. And in the past, stereo vision had 2 disadvantages. And this was for flat surfaces, as Miro has shown on the white wall. It couldn't detect any matching pixels, so there was a lot of error. And the second was that the stereo matching algorithm, which Miro also told you about in much detail, was on the host processor, so it consumed a lot of processing power. And these 2 things have changed. And these 2 things have changed with the projector. the IR projector that Miro has told you about, and the D4 ASIC chip. So the whole processing of the stereo matching is offloaded from the host processor onto the camera itself. And that made stereo vision very competitive. And this is why we also see, and we can just amplify what Miro has said, it's for 70% of all applications, stereo vision is ideal. It's inside and outside. You can have multi-camera setups. So it's a good choice of 3D technology for most applications. So why did we build an Ethernet version of what Intel already has in the portfolio? And as we distribute also the cameras and also the modules, we had a lot of customer feedback. And there were challenges our customers had with the USB connection, especially if there are moving parts and the USB just disconnected, like if the camera was mounted on a robot and it was moving and touching the cable that was easily disconnected. The second one was USB cables, especially if they are long, they act like antennas. So if there are a cell phone near or a microwave or any other radiation source, there are problems with the packet data that is transmitted via the USB cable. And the third problem that we have seen with customer applications was the cooling of the camera via the open slits in the housing. Dust came in, especially if you're near the ground. Then the camera deteriorated and you cannot close it because then the camera overheated. So these were the challenges, and this is why we decided to build an Ethernet version with an M12 Ethernet connector. You cannot disconnect it, it's threaded, so you screw it on and then the Ethernet connector and the data will not be lost. The second thing that you can do with Ethernet, and we are transmitting via the GigE-Vision protocol, is you can go through 100 meters. So also for large distances than the 2 to 3 meter cable lengths of USB, which is limited, you can overcome. And we have a housing which is completely closed and sealed. The standard is IP66, so completely closed. You can put water on it, you can put dust on it, no problem. We can go for IP67 on a project basis, but we need other sealings for that. So this will be then a little bit more expensive than the standard camera is. So it's the lock connections, it's the long cable lengths, and it's the water and dust resistance, which our camera has. The key features of the camera you see here on the picture, and I want to shortly go through the components of the camera. And the first one you see here, if you see my cursor, the yellowish one is the module that Miro has just shown you also in the Intel portfolio. It's number one. It's the D430 module you can buy off the shelf from us, from Intel. It's a 0.9 megapixel resolution depth module with global shutter sensors. Right next to it, there's the RGB module that comes extra. And for that one, we use the same supplier as is also implemented in the D435 from Intel. And these are the two imaging modules. These are connected to a large metal plate. We use that metal plate to conduct the heat of the modules and conduct it to the housing. So expected behavior is that the housing gets hot because we dissipate the heat of those modules which are inside the camera of the housing. Number three are the connectors. You see here on the bottom is the M12 Ethernet connector. It's X-coded. This is important. If you buy customized cables, it's an M12 X-coded Ethernet connector and an M8 A-coded connector with 8 pins for IOs and power supply. You can also use power over Ethernet, and you have the option to have external power supply. So you have both options in the camera. Of course, if you use power over Ethernet, the camera consumes about 1 watt more of power, which means that it also gets a little hotter. But these are the two options you have. And this one you can use also for GPIO. So if you want to trigger other cameras, have one master camera, the other cameras are the slaves, then you would use that one. Number 4 is our own designed PCB. There is the ISP on it, which receives the stream from the RGB and calculates the RGB image. There's the D4 chip. This is the magic Intel chip, which does the stereo matching. The stream from the depth module comes through the D4 ASIC chip, and then we've got a large FPGA on it, and the FPGA does the translation of those streams to GigaVision protocol, and then the GigaVision protocol is transmitted via the M12 out. The other specifications are very similar to Intel, so the field of view is the same, and we also have the compatibility with the Intel RealSense SDK, of course, to enable our customers who have designed already with the SDK and with the standard cameras to more or less plug and play our camera and continue developing with the same code. These are the dimensions. The baseline, very similar to the Intel camera. However, as we have to conduct a lot of heat, it's a little bit more in the Z-axis. So we've got 4 centimeters on the Z direction and 5 centimeters in the Y direction. So in Z and Y, it's a little bit larger than the Intel camera, but the baseline is basically the same. And we've got 4 times M3 holes here for the mounting. We recommend mounting on some heat conductive material, of course, so that you don't have any problems with the heating of the camera. This is also orientated on the Intel peripherals. It's just not 2 holes like on the Intel peripheral. It's 4 times. So you've got 4 options to mount those cameras. The targeted applications we see are basically in the robotics field, automatic guided vehicles. It's near the floor, a lot of dust, a lot of dirt. So there you have the clear advantage. For robotic pick and place systems, typically you need cable lengths longer than 2 meters. There the camera has those advantages, and also in the medical field, we have a lot of customers because there are a lot of radiation sources which also interfere with the USB cables. So also in this field of application, you have a lot of advantages using the Ethernet instead of the USB cameras. And to give you a little glimpse on the roadmap, hardware is easier than software. Yes, we are going to do the D415E also. Right now it's the D435E, which means the global shutter sensor with the wider field of view and the shorter baseline. We are going to do also the D415E. The D415 has the D410 module in it, which means rolling shutters, which means narrower field of view, and which means half a centimeter more of baseline. So it gives you a narrower field of view, and it gives you a little bit more accuracy for the longer distances. We are planning prototypes within this year. So if you want to be a prototype lead customer, please contact us. The 0 series, which will be already fully functional, will be launched in the Q1 of 2020. For those of you who have already bought a D435E, the firmware, which is right now downloadable on our website, uses Intel SDK, of course, and has a fixed resolution. If you calculate the 1280 times 720 at 30 frames per second is exactly the limit which we can't push through an Ethernet cable. The next release, which will be end of October, beginning of November, will have variable resolutions. That means you can go down with the depth and the RGB resolution and have higher frame rates, or the other way around. And we have already beta versions of the wrappers. Miro has also shown you the wrappers which are in the SDK of Intel, the ROS, the Python, the C# wrapper. Those 3 will be also implemented end of October, beginning of November. And then in the beginning of December, then you will also have access to the IR image, and you have the full trigger functionality implemented, which means you can trigger cameras. There will be a master camera, the other ones will be slave cameras, and you will have the dynamic calibration possible. And this is important if the camera drops down, or if this is under heavy thermal stress, then you have to recalibrate the camera. You can do it with the calibration tool of Intel right now with the standard cameras. This will be also possible beginning of December with our camera. And then next year, we will also have the full GigE Vision compliance. It's already possible, for example, with the Playora software, to stream images from the camera, but the full GigE Vision compliance will be then next year also with the plug fest of GeniCam. But as you may see here from the slide, we are currently focusing a lot of the Intel SDK because most of our customers develop with the SDK, and it offers a lot of freedom for the customers and also for us to develop applications with it. So that means now I thank you very much for participating in this webinar, and now we still have some minutes left for questions.
Perfect. Thank you both, Miro and Christopher. That was a very informative session. Now we'll go ahead and take questions from the audience, but just a reminder, if you haven't sent in your questions yet, please do so. We do have a series of questions, and I'll ask those, and each person will be required to answer them. So the first question that I have is, if there are two or more cameras in the same space and in the same direction, do they work well? I think this is a question for you, Miro. Miro?
I can also take it.
Yeah. Good. Sorry. Yeah, I have a double muting method. So it depends on a technology used. So if you're talking coded structured light technology or LiDAR, obviously you can have only one camera facing object. Yeah, because otherwise you're facing interfering process. If you go for stereoscopic cameras, you can have literally millions of cameras locked in one room facing the same object, and there will be no any interfering. And if there will be question like, okay, if a camera will be having active laser for illumination of an unstructured object, no problem again, because there's even more points which is making better visibility for cameras. So if you have a stereo, no problem at all. If you're using laser camera based technology with a coded structured light, you can have only one camera in a place.
Okay, perfect. My second question is, or the second question that came in is, why is the IP66 or IP67 important for the industrial market? I think this is a question for you, Christopher.
Yeah, so what we see with the, if it's unsealed, then dust and dirt will enter the camera, and also humidity will enter the camera if you wash it, and this will deteriorate the functionality of the camera. So what we see in industrial environments, which are very dusty and where the machines have to be cleaned quite often, that a completely closed housing is absolutely necessary to guarantee the functionality over years of the camera to work. So this is why in that case it's necessary.
Okay, perfect. And then the other question that I have is, will you have a D415E version available soon? I think you've already answered that. And then the other part to this question is, how do I go about getting on your testing list?
Email us.
Okay, and the email is?
Okay, so there are two types of tests. First, we've got beta releases of the software, like the ROS wrapper. And the second one is if we provide a new product and you want to be a prototype customer. So one is like you are already a customer and you need a software, and the second one is you want to test a new product. And both are the same way. You contact our sales or you contact me directly, and then we see what we can do and how we can work together.
Okay, great. Well, I think that's all the questions that we have, and I thank you guys for answering them to the best of your ability. Is there anything else that you'd like to talk about before I wrap up?
From my side, from Intel, this is Miro speaking. Yeah, I'd like to really thank very much to Framos team, setting the stage for, presentation of Intel products. I'd like to thank for Framos for very constructive and fruitful collaboration. Yeah. And I just like to assure the audience that, we developed together with Framos very nice products, meeting pretty tough condition in industries. And again, thanks to all calling on the bridge today. Really appreciate it. Thank you.
Actually, before we wrap up, I do have some more questions piping in here. So let's try and take a couple more before we head to the top of the hour. Now, there is one question that says, even if the camera see the reflective sheet that reflected IR light very strong, oh dear, I don't understand that question. It wasn't really represented properly. There's another one. Is there a possibility to shrink the width between the camera lenses?
This is probably a question to Intel. So lenses are the function of a field of view. So there is such possibility if it makes economical sense. So if there's a certain volume you can reach, in talks with Intel or Framos, it's a possibility to change the lenses. We need to touch some features in a firmware. Especially, we need to modify some functions related to the calibration of a depth module. But yes, this is feasible and doable. This is just the scale of the size of your business.
Okay. And then the other question I have, do you have in your roadmap of product a T265 with industrial requirements?
Not really. T265 in reality is a tracking module literally floating and sealed in a resin and in aluminum body. So the tracking module is really fairly well rugged. However, we're not claiming this is for industrial usage, but sealing is pretty good. There's also option to get from Intel something called T261, which is a tracking module as a component. And again, you can have a discussion with the Framos and make it as a truly embedded. Yeah, so both options are available. I'm just saying that the module by default is a fairly rugged. Yep, so this is to answer the question.
Perfect.
Correct. Yeah. In high volumes, like I think we could also do it, but right now the D415 has priority on the roadmap for us.
Okay, perfect. I think there's another question here. We could probably take another one before we head on and go for the day. This is a question for you, Christopher. Can the Framos camera run with a laser at full power without overheating?
Good question. I like it. Because we're going to publish a white paper on the behavior on the camera and how much heat conductivity you need around the camera if you want to do that. So if you run it at full capacity, full frames, there will be still the option to have like ambient 40 degrees, but for sure it cannot be mounted on a plastic box, for example. So then you would need a heat conducting material which it is mounted to, and we are going to publish it, I think, end of next week, beginning of the week after. So within weeks, you will have our internal tests and our recommendations.
Okay, perfect. So we're at the top of the hour. I want to thank every single person for being on here today. We appreciate you being here. We do have a next webinar, which will be scheduled in Q1 of 2020. So keep an eye out for your invite. That's going to be coming out shortly. Also, please do follow Framos and Intel on Twitter and LinkedIn. Here you will get the information on the upcoming product launches, webinars, events that we'll be attending, and any updated company information. Thank you again for joining us today, and we'll see you next time.